And now I would like to invite our third keynote speaker, the director of the Soil and Environment Center at the Agronomical Institute of Campinas, Dr. Heitor Cantarella.
Thank you. It's a pleasure to be here talking about bioenergy, food production, and land preservation. I'm happy that some of the talks that preceded me talked about the fuel versus food challenge, because I'm going to cover this with some examples from Brazil. Well, we know that bioenergy in general is lagging behind the original plans, and at this time we should be producing more bioenergy than we are actually producing, and this means that we are delaying the fight against climate change. And some of the reasons for that is this dilemma: food versus fuel. As Ambassador said, this is not a true dilemma, and especially in the case of Brazil, I think I can show you that this is the case. So we can produce food, fuel, and do it in a sustainable way. Here are some of the highlights of Brazilian agriculture. Just to remind you, some 40 years ago, Brazil used to import food. And Brazil is now agricultural powerhouse. We export food and agricultural feedstock for all over the world. And in the past, we imported food, and we are not a major producer of biofuels as well. So in the past 20 or 40 years, Brazil went from an importing country to one of the biggest players in the food export in the world. And these numbers tell the whole story. But not only food, but also fuel. Along with this increase in food production, Brazil also expanded its bioenergy production. And this is based on sugarcane, especially, but now corn also. So right now, 40% of our light vehicles are run on ethanol majorly from sugarcane, but also from corn. And in addition, sugarcane biomass comprises 14% of the energy matrix in Brazil. And this is done using very little land, 1/2 of the Brazil land, or 40% of the land area used in agriculture. So Brazil expanding food production and bioenergy at the same time for a long time. And how was that possible? Two things: agricultural technology and land and water availability. These are the two major reasons why Brazil succeeded in increasing food and bioenergy production. Brazilian institutions have invested heavily on innovation in food production. Brazilian farmers are open to new technologies, and this is something that helps to improve Brazilian output and innovate in food production. Of course, large-scale operations also help, and Brazil has a story of using modern technologies such as no-till, smart rotations, etc., that helps us to produce food in a sustainable way. And the other thing is land and water availability, and of course a favorable climate. This allows us to have crop intensification, which is very important to increase productivity in the field. And also, it allows us to have 2 and sometimes 3 crops a year. Therefore, we use land very favorably and efficiently. The question that arises is this huge amount of production of food and bioenergy done by overexploiting natural resources? Well, the answer is no. Actually, Brazil is one of the countries that has the most preservation of natural resources. And we are going to see this right now. I ask you to focus on the outer circle of this figure. We see that Brazil land occupies the urban infrastructure, which includes cities and roads, occupies about 3.5% of Brazilian land. 33% of the forests and an area that are preserved within rural properties, in private lands. This number is impressive, and we're going to see this later why. And another 33% of our land is preserved in military and entitled lands, indigenous lands, and conservation units, that is, not private properties. And 30% of our land is used to produce pasture, agriculture, and planted forests. And I'd like to call attention that all the food that Brazil is producing 80% of the Brazilian land, just 8%. And we became a big exporter of meat and grains and everything else. And also a big producer of bioenergy, just using that amount of land. And according to some calculations, Brazil has a potential to replace 10% of the gasoline in the world with ethanol, just expanding bioenergy production in pasture land, that is, not falling any trees in the country. One of the reasons for the large amount of land preserved within rural properties is the forest codes, the Brazilian forest codes. The Brazilian forest code established preserved areas with native vegetation, legal reservations, and also permanent protection areas. These legal reservations are the part of the land that should not be farmed. It must be left with native vegetation. And the proportion depends on the biome. In the Amazon, it's 80%. In southern Brazil, it's 20%. In the Cerrado biome, 35%. This means that the Brazilian farm must set aside at least 20% of its land in conservation units with native vegetation or forests. At least 20%. In the Amazon, if a farmer has 100 hectares, he can farm 20 only, and 80 must be left with native vegetation. In addition to the legal reservation, there's the permanent protection areas. Areas with slope higher than 12% must be preserved, cannot be farmed. And also protection areas are designed around water fonts, lakes, ponds, rivers, and all water bodies must be covered. The areas around those areas must be covered with native vegetation. So there's a very strict law that establish how land is used in Brazil. And farmers are obliged to follow the law, of course. And there's a rural registration system where all farms must have a registration system that is controlled by the government. They have to report how much land they use for farming, for preservation, and all that. Of course, improvements are possible. For instance, many people think that instead of these spots of woods in preserved lands, we should have corridors linking the protected areas so that animals and plants could spread more easily. And of course, we have problems in faraway farms where enforcement is complicated. And of course, illegal deforestation is still a problem. We should not deny that. But illegal deforestation is not a problem of police, it's a problem of police. And well, let's move on now to talk about the Brazilian energy matrix. Brazil has one of the cleanest energy matrix in the world, which can compare the figures of renewables in the Brazilian energy matrix. In average, in 2023 is 49% of our energy is renewable, compared to the world average of 15% in 2021, and OECD countries of 12.6%. I'd like to call attention to the bar in the left side here. The green bar represents the amount of sugarcane products in the matrix. You can see that sugarcane products are the largest contributor to the renewable energy among all the sources in the Brazilian matrix. And now a larger picture. Again, 49% of the energy in Brazil is renewable, 51% not renewable. And I'd like to call attention to the sugarcane biomass in the right side. 16.9% of the whole energy matrix in Brazil comes from bioenergy, sugarcane biomass. This is more than natural gas and coal summed up. This is a huge achievement for the Brazilian economy. And here the feedstock for ethanol. Ethanol is key in our transportation system. We can see that sugarcane is the primary raw material, accounts for 84% in the last data that we have, 2023. But we can see that corn ethanol has an increasing share of participation in ethanol production in Brazil. And this should continue to grow because there are more than 30 new plants announced to produce ethanol from corn in Brazil. And one of the important points here is that both this feedstock, sugarcane and corn, can be grown everywhere. There are more than 100 countries in the world that produce sugarcane. If at least part of it can be transformed in biofuel, we will have lots of biofuel around the world. And of course, the same with corn. Corn is grown everywhere. So there's opportunity to expand biofuel, ethanol, especially ethanol, in many countries making use of these raw materials. Here, I'm going to move to another issue, the issue of sustainability. This is the land use change calculated in a study by Cherubin et al., published in 2021, where he compared what was the payback time to compensate for the loss of soil carbon when sugarcane replaces first the Cerrado area, with a kind of wood vegetation, pasture, and also cropland. In the first case, the huge stock of soil carbon present in the Cerrado makes the transition very expensive, because there's lots of carbon that was in the soil that is emitted to the atmosphere when the soil is transformed to sugarcane. So Querubim calculated how long it would take for the system to pay back this deficit. And the average amount of time was 8 years. 8 years after sugarcane established in the system, it equilibrated and compensated the carbon was lost. When pasture was the case, was replaced by pasture was replaced with sugarcane, the pay time was only 2 to 3 years, much less. And when cropland was converted to sugarcane, there was no payback, because in the beginning the system already had more carbon in the soil and in the system than it lost with this transition. The point is that in Brazil, Cerrado replacement with sugarcane is very insignificant. It's less than 1% of the case. And pasture is around 70%, and cropland about 25%. This means that the most expensive, let's say, system is, in the case of Cerrado, is very little in the case of transition. Usually, sugarcane is expanding in the pasture land. That's the most important. And after 2 or 3 years, the debt is paid, and all the energy, the bioenergy, and the carbon that accumulates in the soil is net gain. So this brings a new data on how we can manage the deficit of carbon when we grow sugarcane. Another question, is large-scale bioenergy just viable in rural areas where land is inexpensive and labor is plenty? Well, we will examine this using the example of the state of São Paulo. Well, you are in the state of São Paulo. We are in the capital city. You see how many cars are running here. You can imagine how much energy this state expends or requires. The state of São Paulo has 24.8 million hectares, which is about 5% of Brazilian land, but it has more than 20% of its population. Population in São Paulo today is 45 million people. This is the heart of the industrial zones in Brazil. So most of the industries are concentrated in São Paulo. It means lots of energy required. And São Paulo has more than 30% of the Brazilian GDP. So lots of business here, lots of energy requirement, and yet 57.3% of the energy in São Paulo is renewable. 57%. This is more than the Brazilian average in a highly industrialized and populated area. And here one figure about the energy matrix in São Paulo, 57% renewable. And I'd like to call your attention to one number here where there's this red mark. 33% of this energy comes from sugarcane and ethanol. Sugarcane's byproducts and ethanol. So in a highly populated, industrialized zone, bioenergy plays a key role in supplying energy to the system. So this means that São Paulo is an example that bioenergy can be very strong, very important, even in industrialized countries, in industrialized areas. São Paulo would be a developed country if set apart from the rest of Brazil. Its economy would be equal of many of European countries. Therefore, this is an important component of our discussion here. So some take-home message: large-scale bioenergy may not be equal for all countries, of course. There are countries that have more land, there are favorable conditions like Brazil, but we've shown that there's plenty of opportunities to grow bioenergy even in highly urbanized areas. Sugarcane and now corn are suitable feedstock grown in many countries, therefore are many opportunities to expand bioenergy production all over the world. Bioenergy generates jobs, brings technology, and improves the infrastructure in rural areas. And all this, jobs, technology, infrastructure, helps to produce food. Therefore, it's not food versus fuel. It's food and fuel. That's the equation that we propose here. And large-scale bioenergy also possible in highly industrial areas, as we show with the example of São Paulo. And it is time to recognize the true potential of bioenergy production and deployment. So with this, I stop my talk. Thank you very much.